welcome everybody. Thank you very much for joining us today. As you know, today's an opportunity to have some interaction with Katie on behalf of MBIE, to ask any questions you might have about the methodology, raise any feedback, and really that's all it is. So it's a very open session.
Yeah, so this is Ferran from Fletcher Building. I'm here in the room also with Pratesh. We are from the Innovation and Sustainability team. So yes, first, thank you for moving us into the right direction and trying to make low carbon buildings. We just had a couple of notes that we sent around already, and I just will touch based on a couple of the ones to see what answers you might have on that one. The 3 points. One will be on the carbon benefits part of it.
Yeah.
Which is linked to the whole biogenic, our lovely biogenic carbon.
Yeah.
And then the second question will be on databases of embodied carbon. When I was reading the methodology, it seemed that you separated the carbon emissions and the benefits.
Yeah.
And then within those benefits, it bundled together actual benefits such as the biogenic carbon and carbonization and concrete, and module D, which for me is a potential benefit that may or may not have 50 years from construction. That feels a little bit odd to me to bundle those three things together.
The intention, and I've tried to kind of put it across in the very simplified kind of bar chart at the end of the document. So on page 19. So that the intention is that is exactly just to separate out anything that's and by the way, if anyone can think of a better name for the benefit, I mean the Finnish call it the carbon, they separate out carbon footprint and carbon handprint. They talk about the handprint being climate benefits, i.e. removal of carbon dioxide or greenhouse gases from the atmosphere that would not have occurred if this building hadn't happened. So but anyway, I just call it carbon benefit because that's the best we could come up with. So the idea is you have carbon benefits that might happen, in what I've called, today, and then you might have carbon benefits that happen in the future. So that's right, those, module D, and recognizing that module D isn't always benefits. They could be net emissions as well. So they could be above the line. But in that chart, I've kind of shown them as an example of where there is a benefit from module D. So say it's a recycling thing. So that happens in the future. So that's the module A benefits. That's where you would put the biogenic carbon storage kind of benefits. So so that's my intention was to kind of make things transparent by separating out the benefits so that we're not amalgamating negative carbon numbers with positive and negative, and carbon is negative and positive isn't a very helpful way to use those, because when I talk about a negative number, that's a benefit. So yes, I've probably confused the matter by bringing it up there, but the idea was to make sure that we're never kind of amalgamating negative and positive numbers and kind of not hiding, but just being very transparent about where they are and about where they occur and whether they're happening today or in the future. So yeah, if that's not, so what were remind me again what the three that you talked about? Biogenic carbon, benefits from recycling. What was the third thing?
Carbonization of concrete.
Oh yeah, okay, yeah. So I guess that would be module B, wouldn't it? So they'd fall into that kind of future benefits.
Even if it's future, though, that is very likely to happen.
Okay.
While the module D may or may not. And concrete does carbonize in the first.
Okay. But so you're saying that the carbonation effects, the benefits of concrete carbonation are more certain than the potential that this end of life scenario might occur. Yeah, okay, that's a valid point. Yeah, get that. Yeah.
But to be honest, that graph that you pointed out, it does make things a lot clearer. That
okay.
the text that has at the beginning.
Okay.
So that is good. Related question to this: which of those numbers will be the cap?
Don't know. That's
Okay.
Haven't crossed that bridge yet. At the moment, I think quite a lot of the feedback I've got from the methodology is about things like that. It's about the caps, and it's about things like who's going to verify this. What other kind of things are we going to put around it? There was always a risk. This is one part of the frameworks that we published last year and got lots of really great feedback on. Raised a whole load of issues. But the reason that we're doing this as the next step is because when we said to people, what's the biggest barrier to stop you doing embodied carbon in New Zealand today, the number one thing was the lack of an agreed methodology. So it's like, okay, well, let's start there. So that's what we're starting with. Questions about the caps and roles and responsibilities for the sector and how it might be enforced and implemented. That's all work that is ongoing and we're not trying to address here. I agree, though, it's a really valid point, and I can see why people are why that's of most interest. But I'll just be honest and say I don't know. I mean, maybe it's what would be another way of putting that is this separating out the emissions in this way, today and future carbon benefits, carbon emissions. Is that an effective kind of framework that we could put caps on in the future? What do people think about that?
From my point of view, and anybody else feel happy to join, it makes it transparent, which is a good start.
Yeah.
So
yeah.
I do like it to at least you show that there is things now that are certain, there is things in the future that are potential.
Yeah.
I do agree with that. Nick, where
Yeah.
Yeah, hi, Ferran, Katie, and everybody. Ferran, your point about grouping.
Nick, hello. Yeah.
Hi, Katie. About grouping B, C, and D all onto the one bar initially. When you look at what some of the actual things involved in that are, like D, as you say, is very much quite potential, quite unknown, and quite in the future, but definitely, a key thing to capture that there might be this, in some cases quite large possible future benefit, but there's a big question mark over it. It does feel a little bit different to C, which is the building will have an end of life at some point, and there will be some impacts to that. That is going to happen. There's still some uncertainty about what level of impact it is. And then there's B, which is more likely, we know that the building is going to be used, and there will be implications of that, whether it's carbonation or it's facade replacement or what. So whilst I think the idea of creating a quite simple, just 2 bars bar chart to make a simple summary is good, we are starting to come back to the idea that it probably is still a bar for A, a bar for B, a bar for C, and a bar for D, but perhaps with the idea that is in the methodology of having the positive part of that bar being the impacts, and the below the line being the possible benefits associated with each stage. I think that would be quite a clear graph. And if people want to know what the sum of any one of those 4 things is, they can do the sums. I mean, I think this reporting is going to come with, I think, Katie, I've shared with you, and it was in the paper that we produced at the end of at the start of last month, this idea of having a table where you're going to present a lot of the numbers, but maybe highlighting a couple of them in particular, but not saying that's the only number. There are obviously lots of things that sit in the background, and I guess it's a question of how much of the methodology does it need to prescribe in terms of what the summary numbers need to be and what the background numbers need to be that need to be reported.
I think I'll just quickly chip in that I think when I wrote this, I realised I was kind of committing LCA crime by putting, module D in amongst, C and B, because it is obviously beyond the system boundary, and yeah, so you know, interesting to hear your feedback on that. And yeah, 4 graphs that A, B, C, and D go above and below the line. Yeah, maybe that's an approach. I mean, you can see that one trying to balance kind of simplicity and accessibility with
absolutely
robustness and you know, credibility.
Yeah, I think
overall,
keeping D on the radar is important though, because
yeah,
you know that.
thanks.
Yeah. Overall, I think the idea of kind of today and future separation makes sense. Like I was just on a webinar with the New Zealand Institute of Architects talking about this topic because they're trying to get their members across it. And, you know, the feedback from them was that, you know, embodied carbon is here and now, whereas operational carbon is over 60 years or 90 years or whatever the life of the building is. And so it's one thing to kind of say, hey, you know, embodied and operational are, say, about even in the New Zealand context or in some countries 80-20, but the difference is you're comparing one thing that's happening in 1 year to one thing that's happening over 60 years or 80 years or 90 years and adding it all together, you know, and there is that uncertainty about what's going to happen with the electricity mix and what, you know, there's lots of, and you've got the ability to change the operational energy, whereas you don't have the ability to change the embodied, you know, at least the upfront part once it's locked in. So I think the idea of like today and future is potentially good, but I do see the issues with adding module D in there that the life cycle assessment community as a whole would probably, you know,
consider a crime.
Yeah, exactly. You know, but you know, because it is a different product system, it is the future, and it's whatever. But I really strongly do believe it needs to be in there because you know, from a metals industry perspective, without that, it's a non-starter. You know, you need to have you need to have the recycling potential because the material has inherent value, and so it's going to be recycled. You know, and you know, metals have high recycling rates in every market in the world for a reason because they have high inherent value. That's not going to change. You know, I don't see that changing ever. Like it's just an inherent property of the material. So you know, maybe separating the module D, or possibly B and C separately, but I guess the thing is that C, the numbers are always going to be pretty tiny. So it's like, you know, you're putting more work into things that's a margin, diminishing returns.
Yeah.
I wonder if that, just picking up on that, Jeff, if that makes sense as well. If you separate them out, the whole lot is future, but then also giving an indication of timescale. So future for B is, you know, 1 to 50 years. Future for C is 50 years or more if design life is greater, and then under D kind of showing that next product life cycle, just to really make it nice and clear.
Okay.
Because you're doing the calculations anyway with that note to, you know, C is small, but if the calculations will be done. And it would, I think that would help people also to understand where those impacts are happening and benefit.
Just Jeff, just to pick you on that kind of locking in comment. So on the you know, discussions I've had with Elrond, and people be aware that Elrond Burrell was my colleague who's performing the similar role that I am, me leading embodied carbon framework, he's leading the operational carbon framework. He's always very keen to point out that, you know, when you build a new building, to what extent you do lock in the operational emissions. So I don't know, it's just a kind of terminology thing, you know. He's like trying not to build, we shouldn't be building buildings today with the idea, with, you know, knowing that we're going to have to retrofit them to reduce their, you know, to improve their thermal performance in the future.
It's a good point, and I think all of our points are valid, right? And you want to deal with the, you know, if you're you want to build a good thermal envelope now, you know, because you can't do it cheaply or easily later. The point I was making is more that you can retrofit the grid, you know, so the electricity emissions can change. So even though you can, you might have the same energy intensity, but you can have a very different carbon outcome. Whereas the materials once made are, it's already happened. The carbon's already in the atmosphere.
But it is a good point that the two, I understand why you've split them out, but also there is that interrelatedness between them, and you could potentially drive some perverse outcomes through separating out operational carbon from embodied.
Does anyone can anyone give me any evidence for that, like an example where those perverse outcomes have occurred? Because I know, like, we talk about it, you know, theoretically, but you know, I think my understanding, and you know, correct. Interesting to hear people's feedback. You know, more insulation in buildings. We're on a, you know, we're on pretty safe ground there, aren't we? That by putting more insulation on buildings, you're going to get that, you're going to be saving more emissions than you're spending on the embodied carbon of that insulation, right?
I'll just chip in. In Auckland, with some of the thermal modelling that we do, there you can get some perverse outcomes where you create a higher than code thermal envelope for a building, whether it be residential or commercial. But I'm thinking more of the residential space at the moment, just based on some work we're doing at the moment. And you can have a heat buildup issue, and your cooling loads can be quite high. You know, in an Auckland environment, you can end up driving a higher cooling demand if you've created a highly insulated thermal envelope, but that's only if the design doesn't also follow through and go, okay, well, if I'm doing that, I need to provide good ventilation to the building, good means of doing that. How am I going to do that? That is one to watch for, and we've been working on a project that I can't name, but the brief, it was for quite a large event space, and the brief said, you know, we want a really high thermal envelope for this thing to make sure it's not going to be cold when make sure it's not going to be cold in there when we've got events during the winter. And we were able to show through a study that actually backing the insulation level down a bit was a better outcome through the other 6 months of the year, where otherwise you would have been just retaining so much heat.
Yeah.
And that for the small extra heating cost versus the large extra cooling cost, you were better off to actually dial it back.
So that's not actually a trade-off between operational and embodied, though, is it? That's just good thermal design. Is that right? That's not an example of, oh, we've been focusing on embodied carbon and we've driven. That's an example of, you know, thinking, right, we've got to get our thermal envelope really tight and then getting a pivot, which I think is still really important and really valid. But it's, yeah, you're saying is you're potentially driving up emissions because you've got higher cooling loads.
Yeah.
Yeah.
And
okay.
The insulation embodied carbon typically isn't very high, but
yeah, exactly. Yeah, that's my understanding as well. Yeah.
To add to that, Nick, hi, AJ Morris, just recently started at Oculus and member of LCANZ and my own brand Recreation. Agree with all your points, Nick, and as well, something to bear in mind, Katie, is that over-insulating can also have some weather tightness issues as well.
Yeah.
Internal moisture, which can influence the life cycle, decreasing durability. So yeah, that would have an impact on the whole of life.
Yeah.
It is the problem for Ran here again. Is the problem you are saying, like in a cold climate, that if we put a cap on embodied carbon, and then we would put less insulation, and that might affect the operational energy used during the lifetime of the building? I think that's the one that I heard a little bit more, that if you put a cap on embodied and don't link into operational, people might choose to put less insulation to prevent going through the cap, and then you will just need to use more heating power. I think that's the one that can be a little bit tricky then, if that makes sense. But yeah, I'm not sure. I haven't seen any of the numbers if that can actually, if the insulation alone can actually be, you know, affect so much.
It might come into play more if there's a conversation going on about thermal mass and how that's used, rather than just straight insulation, because that's probably going to be a higher embodied carbon element compared to just a bit of extra pink bats. Just coming back to the theme around time and building life, something we've been thinking about is, you know, an LCA for a specific project for embodied carbon doesn't change that much between a 60-year design life assumption for the building and a 90-year design life assumption for the building, but it obviously has a larger effect at a whole countrywide system level, because you're displacing the need for another building to have to be built from year 60 to 90. But at the moment, it's difficult to see how projects could demonstrate a benefit under the standard LCA methodology. And this is, I guess, an open question to the group for a 90-year or 100-year life versus a 50 or 60-year life. And in fact, your 100-year life building will probably record a higher total absolute number because there'll be extra module B impact associated with that extra 30 years. Is there any talk about, you know, having a metric that is annualized at all? Carbon per square meter per year?
Can I just clarify then your opening statement? You're saying so the 50-year design, 50-year, what doesn't change between 50-year and 90? Are you saying the module A embodied carbon doesn't change if it's between a 50-year, you know, building that you're designing for 50 years and a building that you're designing for 90 years? You're not actually changing the physical stuff in the building.
Well, you might be adding 20 mil of concrete cover to everything, and in B you'll be assuming another round of painting, but it's and there might be a little bit of increase in the size of your brace for a slightly higher seismic load for a slightly higher design life.
But Nick, I guess that assumes that the actual longevity of a building is really associated with its durability. I think there's very little evidence of that. I mean, usually buildings, the life of a building is really about its economic durability. I mean, how suitable that building is, and how can you ever tell whether a building is going to be torn down in 30 years or 60 years or 90 years? You just can't.
Yeah, well, I mean, at the moment, the likely total, you know, absolute value of a LCA for embodied carbon for a building, whether it's 30 years or 90 years, isn't, well, from some of the quick tests we've done, it's not radically different. And then so this idea of where do we go with the discussion about longevity of a building, and is it an embodied carbon question or is it not? Because certainly some people make an argument that, oh well, I'll just design my building to be 100 years instead of 50 years, and I've done a great thing, and but then when you try to demonstrate that in the numbers, it's a bit tricky.
Well, also it's kind of, as I was saying, it's kind of spurious because the designer or even the constructor of a building at the point of handover, they have no knowledge about how long that building is going to last.
I'd agree with that, because I think there's always a tendency as well to focus on reuse and other things as well. Like want to design for reuse, want to do all these other things, put a more impact up front, which is good, right? You want a circular economy, but at the same time, there are so many examples of reusable buildings not being reused, or modular buildings not being, you know, deconstructed and whatever, and effectively not fit for purpose. And so, I mean, I'd be advocating for a fixed design life to be considered, whether it's 50 years or 60 years. You could probably just pick 60 because it's the common one, you know, used in Green Star, and it's the typical life of a commercial building in New Zealand based on statistics. And so, you know, like as Sam says, you know, you can't predict what the actual life of a building is. I mean, if you really wanted to, you could probably say distance from CBD, and then work out the life for buildings, you know, and then the ones downtown, they've probably got a 20-year life, and the ones as you get further out, they've got a longer life. You know, you could probably create a kind of metric, but like, it's like basically land premium, right? How much is the land worth? And then the building is worth stuff all. But anyway, long story short, I think, the having different design lives doesn't seem like it would be a working thing. But Nick, to come to your point in terms of impact embodied carbon per annum, that's the way that the Danish system that's been proposed that has caps is kilograms of CO2 equivalent per square meter per year. That's an annualized figure.
Yeah, just to be clear, I'm not saying that I think that's something that we should be doing. I think it's just, as an LCANZ community, it's probably good for us to have this discussion internally, because I think there's a lot of perception outside of this group around the impact that a longer design life can have, and if we don't think that that's actually necessarily there, then, you know, there's a communication piece to do around that, I guess. I mean, I've been thinking that maybe rather than trying to catch that potential benefit at the design phase of a building, if we can catch the real benefit of reusing an existing building at the point where we're doing that, then that can drive the message as well. So when you're doing a significant building reuse and you're getting a whole lot of your A1 to A3 material, your whole of your material for a zero carbon bill from an A1 to A3 perspective, when you see that flow through the numbers, that's when you can demonstrate the benefit in significantly extending the life of a building. So it's kind of like turning it on its head a little bit, rather than trying to say the point where you can grab that benefit is in design of a new building. You say the point where you can grab that benefit is in the design of a retrofit, because you're benefiting from this building that was constructed 50 years ago.
Yeah.
And that's probably enough for people to realize that if they design a new building now to be a little bit more likely to be repurposed in the future, that's a good thing. It's not necessarily going to be captured in the numbers, but they will, if they've had experience of going through a refurb project and seeing that material come for free and recognizing the benefit of that, then that we just have to rely on people linking that up a bit.
Arguably, you could even eliminate Module D on that basis, because you could say, hey, if you want the benefit of using recycled material, then use recycled material. You want the benefit of using recycled steel, then use recycled steel.
And have it as a zero impact
side.
Right?
Because then you can get the benefit on the input side, but the steel industry won't like that. But yeah, that's it. You could argue that.
That's a question for Katie. I mean, would a repurposed building be captured under building code in that way? Would it have to submit?
Well, you apply for building consent if it's a change of use, I believe. I have to check that. I mean, at the moment, and the framework that we went out with last year kind of said, let's just do new buildings to start with, keep it simple. But yeah, I mean, we're looking internally, obviously, actually, I mean, probably not a surprise to anyone in this group, but feedback from both of the frameworks that we got last year, the number one kind of broad agreement, but the number one sort of suggestion for change and improvement was you've got to expand this to existing buildings. So, we're looking very closely at what we can do about existing buildings and how we can turn this approach to, and obviously focusing on operational emissions is a big part of that. But I'd like to, there's the embodied carbon impact of that as well. You're dealing with existing buildings, and I was reading what they're. I mean, Jeff's read about Denmark, and I have actually sent the proposal to people in Denmark and getting feedback from them. But I also sent it to people in Finland, and they've got some nice documents out, and they've sent me their next version, like their next level of detail from their methodology. And I was just reading that, and they, quite explicit about it and say if you're reusing products, it's a zero impact. Is that what we're proposing here, right? That's
how it will be covered under the standards. If you reuse something, you only have to account for the impact of the stuff to repurpose it. So say you got a reused steel beam, you only have to account for the fact that you're basically, putting a new coat of paint on it or whatever. You wouldn't have to account for any of the historic impact.
So Nick, when Nick, you were saying, trying to capture the benefit of reuse at the retrofit, you're saying that could be more than, taking a zero impact for reusing that, or we should be taking a negative number, a benefit that should be counted as a benefit.
I was thinking about it being a zero number.
Okay, right, yeah.
Because that's just really clear, really easy for people to understand. There's something over there that already exists.
Yeah,
I'm gonna use it rather than
not putting any more. I mean, it's the obvious thing, isn't it? I'm not putting any more carbon into the atmosphere, right? Yeah. Okay.
I'm going to keep that thing solid for longer.
Yeah. So I didn't really. I mean, it's really interesting discussion about reusing existing buildings that didn't really get covered much in this document, but that's something that we'll need to think about, and that's a good if that seems like a sensible approach and in line with what others are doing.
I imagine that a significant refurb project would kind of count as a new build anyway. Like if you're stripping everything back to the shell, to the skeleton, and doing a full a really significant refurb, I kind of assume that sort of counts as a new building as well.
Yeah.
It's worth thinking about that a little bit though, because I guess you could get some kind of perverse outcome where it's better to actually put some explosives under an old building. If you don't count the renovation thing, it's better to put some explosives under an old building, crush it for recycled crushed concrete, and then build a new one because your aggregate came for free. And that's not necessarily a good low carbon outcome, but I guess it's probably pretty rare. But you might have cases where you kind of create this thing where, because it applies to new buildings, in the old building we could just demolish it, and then we could then reuse some of the materials or recycle some of the materials, but it's kind of a downcycling argument. Like you could end up with some kind of slightly perverse things, but I guess it probably only applies to a very small number of buildings.
But I think if you were to do that in that instance, if you said, oh well, if I kept the ground floor and some of the concrete frame, and I got that for free versus having to spend the embodied carbon of that, all of that stuff as new concrete, that the A1 to A3 of the new concrete elements is going to be way bigger than the A1 to A3 that you save by getting your aggregate from crushed concrete versus from whatever source, right? Like,
yeah, definitely. I was mainly thinking of if the refurb building wasn't in scope of the policy, but the other one was, you might end up with things where there's got this building over here and I will knock it down because it improves the situation over here because that one's out of scope and, whatever. It's probably pretty unlikely what I'm talking about. Like, but I think you definitely want to be encouraging the reuse of the whole building for sure.
I mean, again, this is sort of thing that we need, if people have got evidence of these perverse outcomes.
I think it's
sort of thing that's really
useful.
Stretch,
what I'm talking about. Like it's,
sure.
I guess, Jeff, probably a more common scenario would be, I'm imagining that I'm just imagining hypothetically that you might exempt heavily refurbished buildings from the embodied carbon parts of building code. But the risk with that approach is that the H1 new stuff, which is around operational performance, might be very difficult to achieve in a refurbishment. So it might put you off doing that. But I agree with you, Jeff. I think the circumstances that happens are going to be quite rare. And you don't really want building code to have to cater for those kind of rare.
For those projects which require building consent, they've got to comply as reasonably practical with the building code, with the provisions of the building code that were there at the time the building was built, except for fire, means of escape from fire and accessibility. So, there's the option of putting something in there that says operational and embodied carbon requirements, which, will be caps at some point.
I guess what I meant, Katie, was that ordinarily I'm opposed to this idea that you might ever combine the operational and embodied one. There's that point about perverse outcomes between the two. But I do think in existing buildings, that's where you might get the perverse outcome, because it's harder to make an existing building perform operationally than a completely new one.
Okay.
What about
I think. Oh, sorry, go.
I was just going to ask, what about the difference between requiring measurement and reporting versus requiring measurement, report, meet a minimum? It's still going to be useful to get information about those projects.
Yeah,
and they are going to be hard to put into a box and to say that they should be meeting X number that other new builds or other buildings need to meet. But it would still be, if we're trying to capture as much data at a national level as we could, it would be quite handy for them to go on the metadata, tick, refurb project and still have their numbers reported, but not necessarily slap them with a must meet cap set number 1. Maybe they have to wait till round 2 or round 3, but at least we've been getting the data off the project set and the lead up to that.
Yeah. Okay, thanks. And that was good stuff about existing buildings and retrofits. Thanks.
Also, Katie, if you're taking the approach of collecting data first and setting caps later, which I strongly support, maybe the whole discussion about what numbers you add up matters less, like in terms of how you present the information, because you have the data anyway, and then you can start to make judgments on how all the stuff starts to stack up. Because you'll find, module C, it's kind of not that relevant really, because the impact of disassembling stuff is not particularly high, and so do you really want to focus a lot of effort on that module, whereas the impact of the module A1 to A3 thing is really high, transporting to site from another, like, I guess what I'm thinking is that some of the stuff might just sort itself out as you get enough data to be able to assess things, and then the cap type discussion can then be potentially had at another time about how you then and like how you add numbers and how you present them, and whether it's A, B, C, D separately or add certain ones together, whatever. You'll have all the data, if you can get that over a year or 2 or 3, then you can start to have a much more informed discussion about how this should look. Like you can presuppose everything, but at the same time, until you've got the numbers and you're kind of really seeing it at the New Zealand level and per region and whatever, it's kind of, we're just kind of basing it on a small number of previous studies, and maybe it's better just to not presuppose too much and rather sort of see the figures as they are and then make informed decisions based on actual data.
And to have those that data be able to be compared internationally as well.
Yeah, although
I mean,
I'm
that
not
is
sure how much good international data there is that we could compare against, but yeah.
Hopefully the more the better.
I mean, Jeff, that's the logic behind the proposals, but interested to hear what other people think of that, you know, with the risks with that we need to mitigate, you know, this you know, desire to know what the caps are, what's that driving, is there uncertainty that that's affecting the ability to deliver, you know, low carbon solutions if we're not putting in hard and fast caps straight away? Does anyone have any views on that?
Yeah, I do, Katie. I mean, I think I mean, maybe as Jeff says, you can't, but I think the industry would find it very useful to know not necessarily what the caps are, but what it is that you're capping. You know, are you proposing that the cap would be on A1 to A3 or A1 to A5 or A1 to D? Because that's predominantly what makes the difference in terms of what materials you choose.
So I guess echoing Jeff's point is, until we've kind of tested all that, you know, got some evidence to base that on, because I want to be outcomes focused. Yeah, I want to see where the biggest impact is, and then put the cap on that.
I understand that, but I mean, ultimately it becomes a sort of philosophical question, doesn't it, about whether you want to be saving carbon in the here and now, or relying on potentially spurious savings in 60 years' time. Sorry, that was a political thing for me to say. I mean, you probably can't comment.
I think I'll stay silent on that.
Yeah.
Hey,
but I mean, yeah, that's the logic of separating it out. Yeah, no, I mean, I take the point that that is the crux of the risk. Yeah.
But I think some of what you're getting at, Katie, and I know we've talked about this before, and I'm sure a few other people have had the thought that, and it's been mentioned now, that there is, like, you know, people want to know what the cap is going to be and what it's going to cover and what the number is, but we all know that there's nowhere near enough data available publicly or otherwise to make that call now with any kind of real solid database, right? So
yeah.
But I feel like some of it is like this, it's become this really big conversation topic. People are getting used to the topic, and now they think, oh, we've been talking about this for a while. We must be starting to get a good idea of where this is, you know, where the numbers are at. But we haven't.
Right.
So that's the message: is, hey, we all need to contribute and pitch in for a solid 2-year data collection phase, so that we can then better set a cap. I think Sam's saying, giving some indication of what that cap might cover in terms of scope is probably useful. And I mean, I think the methodology suggests some of that already. You've got the mandatory and voluntary parts, right? So essentially the cap's going to come, I'm assuming the cap is going to be related to the stuff that's under the mandatory. Stage 1 caps will be under the mandatory stuff, and stage 2 and 3 will start to look at some of the voluntary stuff. So that's kind of laid out, but that I can see it's a tricky message to give to people, which is, we're starting this process. We don't know where the caps need to be because there's just simply not enough data. But if everyone in the industry can, you know, genuinely contribute to that public data collection and reporting phase, then we can kind of get to that point quicker and with a good set of confidence. The other thing that I think
I think there's another related aspect to that, Nick, which is that, I mean, we've been debating that at NZGPC, is that, you know, we've been under some criticism recently about the fact that our tools haven't necessarily addressed embodied carbon enough. But I think one of the things I'm very conscious of is that actually the capability in terms of doing embodied carbon calculations is really, really low in New Zealand. So, you know, having a grace period of 2 or 3 years where you are just measuring and you're letting the industry get used to measuring is actually really what's needed, because lots of the consultants, they just don't have very much experience doing it.
And maybe linked to that, perhaps an outcome of this should be just a solid communications plan. You know, like here's the timeline of what we're trying to do. Here's the process that we're proposing. You know, we're imagining this is going to be a 3 to 4 year window. There's going to be this, you know, we're going to require this kind of metadata. We're going to require this information over a period of 2 years. Then we'll propose caps and it'll look like this. And by 2025, the caps will be in place or whatever, you know? And I think that would probably give people a bit of confidence, you know, like at the moment, I think people are like, they see the Building for Climate Change policy documents and they're sort of a bit panicked as to what it's going to mean for them. You know, do they need to be calculating embodied carbon for every building, you know, within the next 6 months? You know, how quickly do we need to ramp up our capability?
Okay, yeah,
I think
so they need it to prioritize the upskilling.
Here's what we're going to need, you know, by mid 2022, we're going to start collecting metadata for buildings. And it's going to be as part of the building consent, you have to submit how many stories it is, how many square meters it is, what are the ground conditions, is it on a sloping side, is it on a flat side, blah, 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 whatever the other things, cladding type, roofing type, structural system, you know, foundation system, floor system, whatever it is, like whatever you need. Like, and I think Nick's probably set out some good examples of what he'd recommend to collect, but like that kind of information. And then we're going to collect that for a period of 2 years. And then at the end of that 2 year period, there'll be 6 months of analysis where we're going to work out exactly what we're going to do. And then starting on the 1st of January, 2025, or whatever it is, we're going to have the caps officially in place at the lowest level. And then in 2030, it's going to be the next highest level. And then in 2035, it's going to be the next one or whatever, you know, and so that it's super laid out.
One bit you missed out from that, Jeff, is what level of competency it would require in terms of people collecting this data and putting it together.
But I'm guessing what Jeff's saying is that until there's some timelines and dates when people know they need to know this stuff by that point, that drives the upskilling, right? Is that what you're saying?
Exactly.
Jeff?
I'm just saying if it's timetable and it's clear what's expected and when, they'll know, okay, well, for the next 2 years, what we need to be able to provide is the metadata. You know, it's amounts of materials, it's whatever. It's not necessarily we need to be carbon footprint experts. And then the carbon footprint comes in at, you know, 2025. And then at that time, there'll be a simple to use tool for residential that will be web-based and it will be applicable up to 300 square meters. And that'll be the only tool that's used, for example, and that manufacturers can submit the information into the tool and the required format for that will be EPD, for example. And if you don't have an EPD, then you would take an average information, there'll be a penalty factor of 10% applied. Like, I just think if you timetabled out exactly kind of the way you envisage it would happen, that would give people the confidence. So, I mean, this webinar is just on with the Institute of Architects. There's like 300 people dialed in and they're wondering whether they have to do embodied carbon, you know, carbon footprinting starting this year. You know, they've got no real idea of what they have to do when. They, you know, New Zealand government procurement has released this document that says here are the sort of tools that you can use for building energy modeling, for carbon footprinting and life cycle assessment, for green building, you know, but it just lists a whole bunch of different things. It doesn't say, please do this, you know, or whatever. It just says, here's lots of options. And so I think people at the moment are probably just feeling a bit overwhelmed, you know, they don't know what the impact on them is. So the materials manufacturers are wondering, hey, how much is this going to impact our business? Does this mean that we're not going to be able to sell in 2 years' time, or it's going to reduce our market share? You know, the architects and the, you know, engineering consultancies are like, okay, how much do we have to upskill in this area? Do we have to outsource this, or can we do it in-house? If we need in-house capability, how are we going to build that up when we've got a skills shortage and we've got a building boom? You know, and all these things kind of happening at once. If it was like clearly timetabled and you said, okay, you've actually got 2-3 years, here's what we're expecting at these times, here's how we're going to ramp it up, then everyone has this kind of forward plan of, okay, this is, you know, we can do this. We've got to develop our capability. The industry associations need to support their members. You know, we start to make calculations, then we start to build up a clearer idea of what's going to happen. And then caps come, and then caps get stricter. And you know, we've considered the potential negative implications of it like this and whatever. I think that kind of forward plan of activity would be really welcomed by everyone.
Here. Yeah.
Anyone disagree with that?
Yes, I agree too. But working back from our targets, not just working from what we think the industry can achieve now and project it into the future. If we look far enough into the future, then we can work backwards from and create that capability.
Okay, thanks. Yeah.
I guess, sorry, Jeff, I'm echoing your point. I guess what I meant by competency was, you know, you take those 100 architects you were talking about. Are they going to all have to become LCA practitioners?
Well, that's what they're wondering, right? And the answer is almost certainly no.
No, yeah, you know? That's right.
But But that, I think at the moment, it's the uncertainty creates fear of, you know, like, and I think if you lay out what you're expecting to do, it probably isn't going to seem as scary as it could be. Like, it could be like, oh, the heavy hand of government is coming down on us, and the caps are going to be here from the 1st of January 2022, and you're all going to have to comply. Does this put me out of business? You know, that kind of thing. I think there's probably a bit of uncertainty there, which is creating a fear of it. And whereas if you just sort of said, you know, like, and if you view the consultation as actually a way to engage with industry and as a way to bring everyone on the journey, pardon the kind of cliche, but to bring everyone along with you, rather than like, hey, we've asked you for feedback and now here comes the heavy-handed government. You know, maybe it could be, let's all bring everyone along. We want to upskill. We want to kind of bring everyone with us. And here's how we're proposing to do it. You know, what do you think of that? And, you know, and then, okay, if you all agree, here's the timetable, and then we're all kind of committing to it, and then we will go together, kind of more of a Scandinavian model, right? You all kind of agree, you work together. Once you've all agreed, you're kind of locked in, and then you move forward together.
And I think just to, I think clarity around how those LCAs will be done would be useful. As Jeff said, you know, is it going to be a tool that you put data into, in which case everyone can breathe a big sigh of relief, or are we expecting every architect or designer to individually model it and become an LCA expert? I think that would be, because it's not clear at the moment. Yeah.
And Sam, just to put it out there, your NZ-GBC Homestar tool, for example, the one you're developing with brands, I think something like that is going to take a lot of people's fear away. Because it's simple. It's relatively simple, and it's based on like building assembly. So for those of you, you know, it's a relatively simple tool that's like, you know, assembly level. You know, how many square meters of this floor system or wall system or roof system. And I think that sort of thing is going to be easy for people to appreciate and understand, rather than like, oh, I need to take a massive bill of quantities and model everything line by line. It's going to take me 6 months. I think that's sort of scary, whereas the alternative isn't. And I think sort of setting that out and seeing some stuff will help people to sort of realize that it doesn't have to be absolutely terrifying.
And we'd be very happy if MB would reference our tool in this consultation.
From one that things, but we also produce materials, I think it could be really, really handy to have those simple tools with generic information, and that generic information is, you know, freely available to everyone, and you have those averages. And maybe what Jeff, you said, it has a penalty because it's an average thing, and you don't exactly know what you're putting into the building. But then for the ones that we are actually trying to do better materials, that you can substitute with our EPD information in, and then you can say, actually, this is the actual number that we are putting in, because then it basically says the materials producers that we are trying to do better, then it actually incentivizes everyone to do better if you can put your number in.
The dilemma with that, and I don't know whether Katie, you've given any thought about that, is, you know, at the point of building consent, which is usually a detailed design, you know, you claim you're going to use X product with X EPD, but then it gets substituted during the build stage, and I don't quite know how you deal with that problem, Katie. I mean,
well, we recognize that it's a challenge, and you know, and what we need to do is quantify the size of the challenge and the you know, what impact. I mean, it's like a theoretical thing that could be a big problem, but you know, we need the evidence to collect that it is a big problem.
Again,
so, you know, because there's all sorts of things that we could do here, and you know, it comes down to prioritization discussion. You know, what are we going to
but again, Katie,
which area are we going to focus on?
Unless you do something about it, then there's no incentive for a manufacturer to have an EPD, is there? Because ultimately everyone would just use generic data.
An interesting way that ISCA for infrastructure is handling it in this way. So you make your LCA on the design phase, you make your base case, and then when you are actually submitting that you are as built, you redo it again with the actuals, and
we do the same
with and if we do this for a couple of years, then we can see if the problem is a lot or not, and if it's not a big problem for like the 2 years that manage things, well, it's actually not a big deal. Like most of the people, when they specify, it actually goes in there with a variance of 7%. So weird. But if the variance of like the design and as built is 20%, then we actually do have a problem.
So you just block the building then.
So I'm very conscious we have half an hour left. We've had some excellent discussion from about 6 people. And we have many other people. No, not at all. But I would like to just open the floor if there's anybody who has a burning point to make and hasn't felt able to contribute yet. Please either raise your hand or unmute yourselves. And just a reminder, please introduce yourself and where you're from so that Katie can madly take notes.
Yeah,
she's
I'm
trying to answer.
yeah, thanks. Yeah.
If not, we'll go back to these guys having a chat.
I mean, Farhan, you did start up by saying you had 2 points, one about carbon benefits and then one about, I think, databases and data.
Yeah.
Did you want to maybe open? We haven't really talked much about data.
It's the same comment that I was starting now of having this public generic data, and I don't know who would be the custodian of that data and who would maintain it. Ideally, a non-private organization, and that could simplify those default values and remove that uncertainty and fear from people. But then we do need to have that private data from individual products. And I'm not sure, because we've said that we have tools that people can put into a single tool, and this is one of the options. We were recently in a webinar that there were interesting American and European perspective in a similar concept. You could see that the Europeans were going into more of the tool that the European Commission and the governments maintain, while the American says someone maintains the database, but any tool is open to the market. So it brings competition to have the best tool for the architects, as long as they use the same set of standards and the same data. I thought it was quite an interesting. There's 2 ways of doing it, but they both went the standard baseline should be maintained by the government. I thought it was quite a good idea.
Yeah.
Not sure if MB's thinking of something like that.
Well, I mean, I know, tools and the use of data and tools, I'm reluctant to say MB will develop the tool, one tool to rule them all, because I've seen all the fantastic tools that are being developed by lots of people in the sector, and perhaps I don't know, naively, but think it's a positive thing that people are developing their own tools to try and upskill themselves. Again, that's kind of a big point of the methodology, is trying to provide the apples for apples kind of rules, so that whatever tool you use, we know we're kind of in the same ballpark. But actually Fatma, who's on the call, has shared some research with me on potential pitfalls of doing that. So keen to explore that more and make sure we don't fall into those pitfalls. But yeah, the question about
well, sorry, Katie. I think I'm hoping to be able to get the evidence for you from Australia, from GBCA, on all of
that's
right. They've had 200 or 300 submissions, and I won't name a company, but it's all most of them have come from one company, and they've done some analysis on the variability within that tool, and it's massive. There's just no consistency whatsoever, and I think I'll state my case. I do think that you need one tool to rule them all, because I think without it, particularly for residential, where the competency levels I think
we said we would look at doing it for what we called small buildings, which would be standalone housing. And I think Farhan, your point of like having a kind of baseline that's got generic data, and then there's a benefit to going into more detail and perhaps identifying savings from that is something that we'd look at.
Well, just to build on that, Katie, I think the approach that we're proposing in our tools is that you can use a really standardized tool that's very rigid and set out and is very difficult to game, and you don't need a certain competency. But if you are going to use a sort of free-form approach where you just use whatever tool and whatever data set and so on, then you do then need to show your competency to do it in that way.
So you're giving people an option of 2 types of tools.
Yeah, that's right. Either use the rigid kind of bolted down tool, which is very difficult to mess up, and or free for all. But if you do the free for all, you have to be competent.
I think that's a good pathway because it gives options while still providing some kind of baseline, you know. And I think the challenge was mentioned, like all the small scale stuff, right? The smaller guys, it's kind of, for small residential buildings, you have to provide something, right? Because it's kind of that needs to be so easy. It needs to it takes 5 to 10 minutes and you're done. Otherwise, it's not going to happen, you know, like it's sort of too hard. And I think the biggest challenge with the tool use is that, there are differences between the tools, and then they do have different data sets and stuff. But with any tool, it's garbage in, garbage out. And I think the problem is you do get a lot of stuff where there's the inputs have been entered incorrectly. You know, I've seen tools where the operational, like LCAs that I've reviewed in Australia, where the operational energy data has been incorrectly entered out of the energy modeling. So you've done all this detailed energy modeling and you transferred the wrong number of kilowatt hours into the building. It's just one number. How many kilowatt hours were used in the B6, the operational energy phase? Completely the wrong number. And so just the numbers are like totally wrong for the entire study, because they've just entered the wrong information. And so my feeling would be you'd want to have that, you separate the input data from the results, because you're trying to get the data in first. You can do a lot of really amazing cross-checking on that data. You know, you said your building is 300 square meters. How is that you've got 50 billion tons of steel in it, you know, or whatever, you know, like it's just not going to happen because you've entered the unit wrong, you know, and like, you know, you've got this sort of thing where you could just sort of do cross-checks based on square meter rates, other form of things where you could say, okay, that's a sensible number, and these other numbers are garbage. And you could then sort of, you know, from that you could build a embodied carbon, you know, operational carbon type assessment around it. But if you're kind of saying, hey, we need the metadata, we have to have that in a consistent format, my feeling is that you need a system for that regardless, because that's the part you're assessing on. And then if you happen to build a residential life cycle assessment thing around that, cool, you know, and if that happens to be one that's the kind of ready to use version, and there you can also use your own accredited tool, great, you know. But I think it's nice to kind of have that metadata really locked down, lots of sense checking, make sure that's not nonsense, and then you can kind of build from there, you know.
Jeff, by metadata, you're thinking about things like number of stories, frame,
like metadata for the building, so like exactly how many square meters is it, what's the floor plate area, how many stories is it, where is it built, what's the climate zone, you know, whatever it happens to be, like that kind of stuff. And then like you're building quantities.
So, I mean, hopefully, like we did put in on the methodology some suggestions of that, and I'm guessing that I think it was even a question. So hopefully people have, should any additional information be included in the building metadata proposed to be required with all assessments? So hopefully everyone's answered that question. Should be great.
Can't remember, but if we didn't, then we support it.
Yeah. Okay. Cool. I'm just aware that Troy asked a question on the text that I don't think has been answered, Troy.
Oh, missed the chat, sorry.
Troy?
Oh, thanks. Sorry, I was running late, so I'm not sure what was covered and what wasn't, but that was one kind of question that I had in the initial consultation and then in the subsequent one, as to how offsetting would be considered, and obviously credible offsetting.
Yeah. So it's not something that's we're offsetting in terms to how you get to zero carbon building that's kind of, we're not really taking that approach. We're just saying, look, we've got emissions in, you know, from the Building for Climate Change programs perspective, we just need to reduce emissions from the building sector. So we're not really looking at offsetting and how you would do that, but recognizing that it is an issue for, you know, organizations that are certifying themselves as zero carbon, and ultimately, of course, I mean, the whole country being zero carbon, then we will need that credibility to make sure that whatever our emissions are that we're saying, you know, whether it's from this building or all buildings in New Zealand, these are the emissions. They obviously, I mean, that's fundamentally they need to be credible, so that we know that we're having an impact and actually reducing the emissions to the atmosphere, but B, if people are paying for offsetting, they're paying the right amount and doing the correct amount of offsetting. So I guess it's the kind of next step beyond this program.
What I was so where I'm coming from is more in terms of, so if eventually a cap is put on, still obviously being a large component being considered under the scheme. And we are developing our own offsetting program. So we don't want to be disadvantaged because we actually have already gone through a process of calculation and offsetting.
Yeah, that's okay. Sorry, I didn't understand your point there then. Yeah, so that's not something that we've addressed at all in the methodology at the moment. So that's, yeah, a good point. And if that's something that you're working on, you know, as an industry and a sector, then yeah, we should, yeah, make sure we're taking account of that.
I wonder if that could be captured as a third part of the bars in the results, so that you've got the, I know, right? Sorry, but you've got the impacts. I know, but you would need to split it out because the emissions have still happened, but then recognizing that some of those have also been offset.
Yeah,
I think it would need to be separate. You couldn't just.
Yeah, I mean, okay. I mean, I suppose perhaps that's one answer, Troy. Is do we what do we need to do to consider that as a carbon benefit in the terminology that's been used in this methodology? That, you know,
and I think that probably is the most logical way to do it, because then that accounts for any differences in the calculations that happen outside of your calculator. So it kind of moderates across. So if you're using whatever MBIE uses as it's calculated to calculate the carbon, and then whatever the alternate offsetting calculator has developed, it's kind of a cross-checking as well.
Yeah, okay. I don't know how that's, I mean, we've said, I know Nick might want to talk about standards. So I say this with some trepidation, but how offsetting is recognised or not currently in those LCA standards, and in the LCA framework, that's beyond, it's beyond the system boundary and even beyond the Module D system boundary.
It has to be reported separately.
Yeah.
Okay.
Did you mean this Nick or other Nick?
No, I meant Nick Collins.
Yeah.
Sorry, Nick Carmen. Yeah.
Collins is remaining silent. You're muted, Nick. If you would like to speak, do unmute yourself.
Thanks, Katie. I wasn't proposing to respond. I'm listening and learning. Thank you.
Okay. All right. Sorry, I don't mean to put you on the spot, Nick.
No, that's fine.
No, appreciate you being here. Yeah.
Oh yeah, as Jess said, it needs to be reported separately, but by reporting it separately, it would also help to recognise it.
Yeah.
One broader question I guess I have in my head about all of this stuff is that MBIEs, you've got the delightful task of dealing with a consumption-based metric. You know, if buildings are consumers of stuff, and then you've also got all your other target areas which are producers of stuff. So you've got industry making stuff and the electricity sector making energy and whatever. And you've also got the land use and land use change adjustments that take place at a national level. And so you're kind of picking, you're taking bits out of lots of different pies and kind of reallocating them to buildings. And so I guess I just wonder what the overlap between those two things is. So you've got something that's like, you know, one of the target areas is agriculture and forestry, and then you've got another target area for industry and heat and power and things. And so I guess I'm just thinking about how that works, because like, so the offsets kind of happen, but if they're forestry offsets, they're kind of under this land use and land use change thing. But equally also the manufacturing of building products is happening in the industry part of the number, and so you've got all these different sort of bits of the thing coming together. And this is not so much a question, but it's more just thinking about, you know, there's it's not a double counting issue necessarily, because reducing impact is a good thing, but it's more just like how those two things relate to each other is a little bit complicated, because you've got some direct emissions associated with buildings, but they're so tiny, they're not really that important. And then most of your emissions are kind of indirect, taken from other sectors. And then even with the offsets that Troy was talking about, they're also happening in a different, you know, part of the ledger, which is the land use and land use change. And so like, it's kind of like you take from this and then you're offsetting here, and then it's like everything's kind of just cut separately and then grouped.
Yeah.
And so then how do you then account for all of those different things, both the positive and the negative, is a bit interesting because it's kind of happening also in someone else's domain as well.
Yeah. Well, from a government perspective, you know, the key, what's you know, the Building for Climate Change program is holding the pen on the building and construction sectors part of the National Emissions Reduction Plan, which is the government's response to the Climate Change Commission's advice, which will be consulted on. So that emissions reduction plan, you'll be pleased to know, is another consultation coming out soon and will be finalised by the end of the year. And my understanding is that we've got 5 sectors in that emissions reduction plan: waste, land use, heat, industry and power, and I think it's changed now. I think it's, anyway, that you know, industry and power, buildings and construction, transport. Yeah, so they're the 5, and yes, there is significant overlap, and how we see ourselves in the building construction sector is the driver of emissions in those other sectors, and or driver of emissions or benefits from offsetting, if it's planting trees to achieve to offset emissions. So yeah, the idea is that emissions reduction plan is where that all gets joined up, is the high level answer to your question. But you know, to me, it's more important. Well, it's not more important, like that is important, but the you know, fundamental, what we're trying to do is just reduce emissions from the building and construction sector. So you know, and it's split between operational and embodied emissions, and I just try and keep coming back to that. That's the end goal. You know, and I appreciate the, you know, the complexities in accounting and offsetting and trading schemes and things, but I just try and bring it back to that. Okay, where are the emissions happening? We're driving them. So how can we, by designing buildings better, building buildings better, operating buildings better, how can we reduce those emissions, whichever line of the ledger they come out from? And I guess the other thing is, sorry, just quickly, is that the Climate Change Commission's advice talked about, they got a lot of feedback on their draft advice on consumption versus production accounting, but they're sticking to production accounting. But the line was something about encouraging the direction of government policy to take a consumption lens. So that essentially gives us the mandate, as you know, as we see it, for what we're doing. We're not doing the direct, you know, there's very little direct emissions from buildings, but we're the driver of a lot of emissions.
So with that in mind, and given that you're the one consumption-based thing of the 5 and the other 4 are all production, I guess the thing that I was kind of thinking, just like taking Troy's idea further there, you know, from the perspective of purchasing offsets, you're driving a higher land use change offset at a national level. Like if you're thinking, okay, what are we trying to achieve? We're trying to achieve our Paris commitments, because that's kind of the goal of all of this policy, right? We want to achieve our Paris commitments. Like I guess I always think in the lens of gross emissions, right? Like I don't forget about all the other stuff. But carbon footprint of the planet. But the carbon footprint of the planet is the gross minus the the stuff that's sequestered out, right? So like, I guess what I'm thinking is just thinking logically through it. If you're saying that we've got the production side and we've got the consumption side, and you're the one on the consumption side, you're the building and construction sector, which is taking stuff from all these other things, you're driving some emissions up by using stuff, but you're also potentially driving some emissions down by planting more trees, for example. And so I guess from the perspective of the consumer could be consuming carbon neutral product, which is driving, even though there's gross emissions are going up, net emissions could be staying similar, because you're also encouraging a different bucket to move as well. So I guess from the perspective of consumption, you can consume emission sources, like, you know, making a product, but you can also consume offsets for those emissions, which potentially drive up our land use change negative adjustments. So when I get to our net emissions, so I guess that is an interesting point there, because even though in the EPD standard says no, forget about it, you're just taking gross emissions and you report on the offsets separately. You know, arguably from a demand side measure, you do want to stimulate the planting of more trees or the offsetting of emissions through other measures. And so there probably is merit in reporting on both. Maybe you do it separately, but effectively both are welcome, right? So you want to reduce gross emissions, but you also want to increase the, you know, carbon stuff that's taking carbon out of the atmosphere.
Okay. Yep, good point. Does anyone else have anything to add on that?
Jeff, can you give us an update on where things are at with the European standard in terms of allowing sequestration to be included in?
So you're talking about EN 15804A2. It effectively is similar, but it changes the way that end of life is dealt with for timber products in particular. So landfill of timber will no longer be allowed to sequester carbon under the new standard. It's all artificially re-emitted after a 100-year time horizon to avoid giving any benefit to landfill, which doesn't reflect the reality of the situation, but it reflects the political environment in Europe, where they want to discourage landfill and they want to discourage incineration. So what that means is if you add together modules A1, A2, and so A, B, and C for a timber product, it means that the biogenic carbon cancels out over the life cycle.
So there is no sequestration effectively.
Correct.
Yeah.
If you're taking A to C to get A to C together, if you then account for D, then you get a reuse recycling potential, but effectively it cancels out the benefit of the biogenic carbon.
All right, so that's the new standard in Europe. So how does that impact on us here in little old New Zealand?
We choose what we want to use, but the new standard in Europe replaces the old standard mandatorily by July of this next year. I think there will be no ability to use the old standard, the A1 standard, from next July. It's officially gone. Yeah. So the EPD Australasia and the international EPD system are using a 1st of January cutover, but the standard itself, I think, has written into it that as of the 1st of July next year, the old standard shall no longer be used. So it is kind of null and void. So arguably, in the New Zealand context, we kind of have to use the old one, the new one, because the old one no longer officially kind of exists as of the 1st of July next year.
Although the central government chooses what standards we use, right?
Yeah, but what I mean is, I guess, is that EN 15804A1
any
doesn't
new
really
EPDs.
exist as well, not only any new EPDs, but the standard itself is no longer valid from the 1st of July next year, is my understanding. So EN 15804A2 replaces, and thou shalt not use at all ever, EN 15804A1 beyond that point. So it effectively fully replaces it, and the old standard is retired, is my understanding, my reading of it.
Well, I was just going to say, my understanding is that any new EPDs done after July 2022 have to be done in accordance with 15804A2.
Yeah. And I guess the thing you've got, though, is that EN 15804 isn't a building standard, it's a building product standard. So when it comes to what the government does here, the relevant standard is EN 15978, the sister standard. And that's nowhere near the level of detail here. And I don't know what the time frame for revision on that one is. And then you've got the challenge that the ISO standard that mirrors EN 15804 is based on A1. So ISO 21930 is based on EN 15804 A1, doesn't mirror the latest changes. Therefore, A2 and ISO are in conflict. And there's no, you've got to have I don't know what the timeline for revision of ISO 21930 is. And also then that doesn't also relate to buildings either, that relates to building products. So even though they're related, they are different. Does that affect what MB does? Not necessarily, but yeah.
So Jeff, the knock-on of that would presumably then would be that those trying to claim a massive negative carbon benefit from building out of a big timber building will not be able to do that.
They would within module A.
Module A, yeah. But arguably, you could say that you shouldn't account for biogenic carbon in module A. Yeah.
But hang on. But it gets. If you're doing A1 to D, then it would all be re-emitted in module D. So you're
module
not,
C.
module C. Sorry. So you're getting no.
If you do a full life cycle, effectively you get no benefit from biogenic carbon.
Yeah. And as you said, if you were just doing A1 to A3 or A1 to A5, you wouldn't be allowed to do it either because you're.
Well, that's the other change for A2 is that you can't do EPDs that are just A1 to A3, you have to include modules C and D.
Right. So I'm right in what I just said.
Yes.
You couldn't do an LCA for a
if you add A, correct. If you add A plus B plus C, which is fair, then the biogenic carbon cancels out, because it is cancelled out from recycling and reuse. It's cancelled out through landfill, and it's cancelled out by incinerating because it actually re-enters the atmosphere. So yes, that's correct.
Which partly brings us back to the question of, does the cap sit on module A or module A, B, and C combined? Because that could really have a big impact.
Which and you know,
I'm not expecting an answer now, Katie.
Yeah. Well, no, exactly. But I think it also you know, I feel like it's the transparency thing, right? It's, you know, if the people here in this room are trying to grapple with what are the changes that, you know, what's going to mean in the future, then how are we going to expect the rest of the sector to do it? So to kind of insulate us against that is just to kind of, okay, let's separate out biogenic carbon and yeah, as the settled science standards change, we can be clear about what we're doing with it. It's not amalgamated into any other numbers is another kind of, for me, very important reason for doing that. Well, and also very important for separating it by time as well, because, you know, that's, I mean, the point that going back, we've talked about it a number of times, but that idea of the time frame and, you know, whether it's today and future or A, B, C, and D, and Emily's point about, you know, maybe having timelines on it. We're reporting, it's been quite an interesting thing for me over the last sort of few years, thinking, I tend to think about the life cycle of a building, but actually, you know, that's not what the government cares about. The government cares about emissions in 2019 and emissions in 2020 and emissions in 2021 and emissions every single year from now until 2050, well, and you know, and beyond, obviously, but you know, that's where our change has got to happen. So irrespective of the fact whether you think, you know, the emissions that those module C and module D are, the uncertainty around them is also just, well, they're not on our radar.
Yeah. I guess my point around being, I know you won't, and you can't have certainty about what you're going to be capping, but the reality is out there on the ground, as AJ just said, you know, there's a perception that building completely out of timber will lower your emissions enormously, and we have government ministers trying to push a timber first policy in New Zealand. But if the reality is that I hesitate to use the word science, but if the
accounting,
if the accounting doesn't account for that and effectively puts timber buildings and other frame types on a very similar footing, and you know, then we're all going to look like we've got egg on our face.
I come back to, you know, we're being outcomes focused and we're looking at how we can reduce emissions. You know, that's in every year between now and 2050.
Yeah.
Nick.
Oh, just that the standards and the science are not necessarily the same thing.
But that's the point I was trying to make. Yeah, I agree. I do agree. Yeah.
I mean, the local environment here in New Zealand is that we don't incinerate a lot of our waste timber, right?
No,
and a lot of it stays, and a lot of it, when it does end up in landfill, stays pretty inert.
Yes.
So Jeff, is there the ability for us as New Zealand to put forward that science and make that claim?
The European Commission is not interested in landfilling materials. So they're also actively trying to phase out new waste incinerators. And that's very unpopular in Northern and Central Europe because we're powering industrial, you know, municipal heat systems, and they've done very well. And so, you know, there is a view, and that view is that we need the circular economy is the dominant concept in Europe, and that's fine. It's good. But the problem is it's not necessarily always a low carbon circular economy. It's a circular economy, and then, you know, and then everything else falls into line. And so my understanding of what happened in that standards process is that late in the piece, the European Commission stepped in and said, we will add the sentence. And the standards committee didn't like it, and we got written in. So my feeling is that the standards aren't necessarily going to change, but ISO 21930 or those sorts of standards might be the opportunity there to have a non-European view. But nevertheless, like, I think the problem with the timber stuff is always uncertainty in the future, right? Because just because it's landfilled now doesn't mean it's landfilled in 2022, 2100. You know, like the reality is that, you know, things are changing, and hey, there's more of a demand, for example, for timber from buildings in, you know, the cement kiln in, you know, Whangarei, and they can burn CCA treated timber, for example, you know. And so I don't know, I think the reality is there's a huge amount of uncertainty. But to come back to kind of Katie's point, there is no way in standards to add together these numbers, right? So the logic that you're applying of let's separate the numbers, let's report everything, let's collect the data, to me is the right way to go, because we can't say hand on heart, this is the way you have to do it. Every industry, every person can add the numbers together differently and you end up with different outcomes. And unfortunately, that's the way it goes. And I guess our job as life cycle assessment practitioners is to do sensitivity analysis. Are the conclusions sensitive to the way you add it together? And if they're not, then it doesn't matter. And the data will be able to support you to do that, Katie. You know, if you've got the data from thousands upon thousands of new buildings, you can then apply every calculation approach under the sun. Do the results change? If they do not, then it doesn't matter which calculation approach you use, and we're capping this, you know, and then you can support through science your approach.
Barbara.
Yeah, I think that's a really good point with the sensitivity analysis and the scenarios and the uncertainty. And that's probably something that we need to, if we use tools, that we also need to make sure that those tools actually cover various scenarios. And yeah, so I think it's quite an important aspect to really look at various scenarios and do those sensitivity analyses. And that is exactly what the ISO standards for LCA also require. And that is what the carbon footprinting standard requires. And I think that that's quite important, not to rely on one number that has been published in one study, but to really see, especially if there are comparative studies, that they actually follow the standards and have all this sensitivity, etc., assumptions tested and are solid results. Because otherwise it becomes really tricky.
Okay.
And if you look at the tools, like building on that, if you look at the tools now, they're often not doing that. They're not doing the sensitivity analyses. They're not doing not the studies that we do one-off would be, but like a standard building LCA tool. It's kind of like, maybe it gives you 1 or 2 or 3 outputs, but it doesn't really get into the detail of what are the results sensitive to, what are the changes in outcome, you know, like they're just like, hey, spitting out a standard report and the answer is X, Y, or Z.
And interpretation of those can be really, really tricky. And that's what the most important part is. I always say, if you're doing
well, maybe that's the role of LCA practitioners in all of this.
I agree with that, Katie, because I love this conversation because I'm a really technical person. But if we put this conversation a little bit onto the public, we'll freak everyone out. So like those simple tools that speak the one thing, it's probably the thing that people can absorb. Any other thing needs to be done by professionals that love technical things, because then it gets otherwise it can get really frightening for other people. And you know, this is really great. I love it, but we just do need to be careful how we do this.
Yes, we are out of time, in fact. Katie.
Well, thanks very much. You know, I've made some notes on, I'll tell you what I've made notes on, you know, the carbon benefits, separating future emissions and today's emissions, trade-off between operation and embodied emissions, reusing buildings, capturing data first, putting in caps later, capability for doing embodied carbon in New Zealand, tools, variance between design and as-built, offsetting and balancing, you know, driving, you know, seeing building construction as well as driving emissions, driving benefits, the opposite of emissions. Yeah, so I've taken away all those, you know, points under those headings. So really appreciate everyone's time. Thanks for that. Hope you found it useful to ask me loads of questions.
Wonderful, Katie. Thank you so much. Thank you for just taking that all in as well, because there was a huge amount of information coming at you.
Well, and thanks very much for everyone who's put in a formal response as well. You know, that'll go well. We've got yeah, pretty good. I'm really pleased with the amount of number of responses we got back, and the the time and effort that people put into it. So yeah, it won't go to waste, I promise.
Thanks, Katie. And yeah, thank you everyone. And Katie, if there's further that you would like from us, please just let us know.
Oh, yeah, thanks for organising it, Emily. Cheers.
Yeah, pleasure.
All right.
Wonderful. Thank you all.
Everyone.
Bye, everyone.